My name is Asti Pawika Aditya, and you can call me Asti. So today I will moderate the session with Miss Ya-Wen Cheng. Hello, Miss Cheng. Miss Cheng, are you there? Okay, while we are waiting for Miss Ya-Wen Cheng, I will read her curriculum vitae to you. So Miss Ya-Wen Cheng is currently an assistant professor in the Department of Early Childhood Education, same as me. She works at Asia University in Taiwan. She holds a PhD in information management. Her research interests lie in the field of the development, evaluation, and the use of learning technologies. This includes the robot-assisted language learning, or RALL, robot-assisted social and emotional learning, or RASEL, and the design and development of educational games. And today she will present us her presentation about the use of educational robots. So once again, I will greet her. Hello, Miss Cheng.
Hello. Hello. Can you see
Hello,
me?
nice
Can
to
you
meet
hear
you. Oh
me?
yeah,
Oh,
yeah, I
great.
can see you.
Thank you so much. Okay.
Okay, did I pronounce your name correctly, Miss Cheng?
Yeah, exactly. Correct. Thank
Oh
you
my
very
God.
much. Yeah.
Oh, thank God I
Thank
pronounced
you
it
for the
correctly.
introduction.
Yeah. Okay, so Miss Cheng, without further ado, let's begin your presentation, okay?
Sure. Shall I
Sure,
begin
okay.
it now? Right now?
Okay, yes, the time is yours.
Okay. Thank you. So
Okay.
maybe hold on for a moment and let me share my
Okay.
screen. Wait. This one. Here we go. So now can you see my screen? I'm sharing my screen.
Yes, we can see it
Okay.
clearly.
Okay. See, let me adjust it a little bit. All right. Okay. So good morning. Thank you for the invitation. Yeah, I was really excited to join the conference and share my work in this conference. So I felt like a great privilege to be here. And yesterday I actually attended keynote sessions, and I also pick up tons of insight from that. I learned a lot. So today the topic I'm going to share with you is somewhat also related to language learning, but the focus will be a little bit different. So the topic I'm going to share with you today is more focused on the use and design of educational robots. And at the end of this talk, I'm going to share with you an example how we use educational robots to facilitate primary students learn language. So my talk actually covers three studies. Okay, three studies, and I will walk you through one by one. Okay, so I would like to begin my my talk with this picture. Okay, it's a little bit funny, but like I think every one of you, anyone in this conference doesn't know this cartoon character. No, right? Because I think this cartoon character is worldwide well known. His name is Doraemon. He's a robot cat, right? Okay. So when I was a kid, I was so fascinated by this cartoon. I always wished that one day I could have a learning companion just like this cartoon cat, like this robot cat. It's being cute, intelligent, and capable of interacting with me just like a human being. So I decided one day that I was going to make it happen, right? I would have my own, maybe a robot cat or a robot bear. But years have passed since then. I still don't have a robot bear yet, but I have a few robot friends, like robot friends companion. You'll see it later in this talk. And right, so okay, So I started to work on the robot project several years ago when I was still a PhD student. And at the time, the educational robot seems to be a very popular agenda or popular topic, while everyone else is talking about using the robots to facilitate learning. But the fact is that I think no one really knows about how to incorporate robot into education, and no one really knows how to use them effectively. So as I review several studies, they all suggest that the robots are promising educational tools. They can help teachers instruct them more effectively. They can enhance learners' comprehension, motivation, engagement, and learning performance. And it can also foster development 21st century thinking skills in students. But even so, as a researcher, it is still unclear to me how educational robot can be used to facilitate learning effectively. For example, what can we use robot to learn? I mean, learn what subject, right? And in what kind of scenario, right? And with what age groups? And most importantly, what are the most important and urgent applications of educational robots? So to answer all these questions, our team started with the research journey. It's a bit long. So we conduct a series of studies about the use and design of educational robots. And we kind of divided our research journey into 3 different phases, as you can see from the slide here. Phase 1, needs analysis. So in this stage, we focus on finding out what are the essential applications of educational robot. And through that study, we identified that using robots for young children's language learning is the most important one, or maybe we call it a killer application. So great, but the next question came up right away, okay? So how can we incorporate robots into young children's language learning, right? And since most of the teachers, they are non-technical background, so how can we encourage teachers to use robots into their language teaching, right? So this is the second question. So in order to answer this second question, we conduct a second research. We develop a system. We call it R&T learning system, which includes a robot and tablets and toys with sensors, and also with the authoring system to allow the teachers to specify the interactions between robots and the toys, and also the learners. And finally, in phase 3, when the system was ready for use, we then used the system to conduct an empirical study as a proof of concept. Okay, so this is an overview of this talk. So now let us move to the next slide. So this is the title of my first study. And this study, we aim to identify the essential applications of educational robot. So in this study, we collect needs from 3 different educational stakeholders. Let me see. Here are the research questions that we posed in this study. Research question number 1, we wanted to know what are the essential applications for educational robot. For example, what can we use educational robots for? I mean, for language learning or physical education or math or science. I mean, what are the subjects, right? And research question number 2, what are the essential applications for each age group? So in this study, we divided learners into 6 different age groups, including kindergartner and preschooler, and primary school students, middle school and high school, college students, adults, and elderly. Research question number 3, in terms of the achievability timeframe, so which essential application can be realized in the short term, midterm, and long term? So by asking all these questions, we aim to find a killer application so we can use the educational robot right away. Okay. So here's the diagram that summarizes the methods and flow of how we collect the data and analyze and verify the data. So in order to answer all the questions that I mentioned earlier, we first of all, we conduct a systematical literature review. We use educational robot as a keyword to search for empirical studies in Web of Science, which were published like in 10 years ago, in the past 10 years. And then we we carry out an experts interviews to collect opinions from the experts. And we also create our own questionnaires, and we post it online for the instructors in different educational levels to fill out. So by doing so, we were able to collect the data from 3 different kind of stakeholders. And then I mean, to be sure, I'm not going to talk about too much details about how we analyze or verify the data. But after we collect the data from the experts, instructors, and researchers and research, we applied card sorting method to classify the needs. And lastly, we'll apply 2 methods to verify the data. One is triangulation, and the other is experts meeting. Right. So here's the results for the first research question. As you can see, in terms of learning subjects, all the data indicate a significant need of using robot in the first one is language learning, and then followed by robotics education and children, and also for children with special needs, also referred to special education in Taiwan. And in terms of roles and functions that the robot is expected to play, they are like teaching assistant here and robot learning counselor. It means that the robot can provide you with, counseling, right? And to help you to understand, you are lagging behind, and what are the, learning strategies you can apply for your learning. Okay, and then also for robot secretary. So robot secretary means that the robot can help the teacher to collect students' assignments, to grade and record the grades, and running errands for the teachers, like that. Okay. So this picture, it demonstrates some of the applications that I mentioned earlier. So on the left-hand side are the pictures that demonstrate using robots for gameplay and for language learning. And the pictures on the right-hand side demonstrate the kind of applications that use robot for students to learn robotics or computational thinking. And to answer the second research question, here's the result. In terms of age group, right? Preschool and kindergartner. This one, sorry. Preschool and kindergartner, they need the robot the most. You can see their demands really high, right, among the 6 age groups, followed by primary school students, and then the elderly. Oops, okay. And also, as we conduct the expert interviews, some of the expert suggest that for high school students and college students, they don't need a physical robot. Rather, a virtual robot which live in their mobile device is more useful for them. Okay. Okay. Let me see. And then at the end, excuse me. Let me see. All right, here we go. Excuse me. So finally, we compile a list of the collected needs and invited 2 AI experts to score these applications that we have collected, right? So they score the requirements based on the complexity and the time needed for implementation. So these needs, I mean, the needs that we collected were categorized into 3 groups. Those can be, the first group is that those can be implemented in short term, and followed by those can be implemented in midterm, and which can be the ones that can be implemented in long term. So the results show that in the short term, robots can be used in kindergarten for robotics education, science education, and for gameplay. So next, the robot can be applied for language learning, and also especially used in preschool and kindergarten age group. So based on what we have found in the first study, we've come up with a new idea of an educational application scenarios. So that is to use the robot and Internet of Things to create an immersive language learning environment for young children to learn languages. So the idea is to just like that. Okay, a robot playing toys with the kids in the living room or in the school. Okay. So the idea is similar to the kids who knows 2 languages or who familiar with 2 languages or fluent with 2 languages. So that kind of kids, we call them bilingual kids, right? They are growing up and hearing us, like receiving a lot of vocabularies and language inputs from 2 kinds of language, and then so that they can pick up both language easily and become bilingual. So we have this idea in mind. So we think that the robot can play as a friend to interact with the children, while at the same time the robot will speak a foreign language. So by doing so, the children will grow up bilingually, because he oftentimes interact with the robot who speaks another language. So the kids can learn another foreign language easier. So this is because human beings, we acquire language through social interactions, right? So language only become meaningful when we put it into practice in a social context or a social engagement. So our idea is to put IoT device inside the toys, make the robot smarter enough to perceive what was going on and what was happening around them. For example, if a child pokes or squeeze the toys, the robot would notice and immediately respond with the right language input and social interaction, right? To what the child is doing, right? So this picture shows that what we have conducted in the past few years. So here are the pictures. Okay, how we use robots to play games with the kids. The first photo shows the robot playing a board game with kids, with children. It's a farm robot, so you will see some animals and farmers here. Okay, and the second one, another one shows that we engage children in language learning we using a pop-up book. So it's actually a pop-up book. So it has 4 rooms: a living room, bedroom, restroom, a living room. And then we ask the kids to play somehow like a pet growing game, right? Within using that pop-up books. Okay, the third one is as we use a supermarket toy set to mimic a supermarket scenario for children, right? To pretend play, right, with the robot. Okay, so what we have done is to embed the sensors like NFC tags or touch sensors inside of the toys. So by doing this, it allows the robot to perceive what the children is doing right away, and so that the robot can produce language input right away correspondingly. So this gameplay learning setup has multiple benefits. So first of all, we create a real life scenario with toys, right? So children, I mean, our learner no longer learn vocabulary or foreign language just using your textbook, which is out of the context. That now they are using the language, learning the vocabulary in the real scenarios. And second, second is that the toy provide a joint attention between the robot and learner, so that the interaction between the robot and children is guided in a structural way. Okay. Because in the past, it's very important to have a joint attention between the robot and children, because in the past, some of the research has shown that if we just let the robot to interact with the child alone, then the child will, because there's no guidance, there's no joint attention, the children would just lose interest very quickly. Okay. So, okay, third, the benefits that using toys for hands-on activity can support children to have multiple sensory learning. Okay, so because they have to use hands to grasp, right, to manipulate a lot of items, so it can foster their cognitive development, right? So the idea sounds all perfect, okay? But soon we encounter another challenges, okay? The challenge is that because most of the teachers, language teachers, they are non technical experts, right? So they have difficulties incorporating robots in their language teaching. And secondly, we are not sure if to support such a learning environment, what are the functions and roles or the appearance the robot should be, okay? So to answer all this question, that's why we conducted the second research, okay? The research, the purpose of the second research is to develop an authoring system that allow the non-technical background users to specify interactions between the robot and the child, okay, easily, okay. And second, we aim to develop a robot and toys with IoT sensors in a learning system. So based on that, we propose these three research questions. First of all, what are the pedagogical needs in integrating robots and IoT-based toys in EFLO teaching and learning? And secondly, how can the authoring system be modified to match the pedagogical needs? And third, what is the usability of the authoring system? And this is our research framework. We actually adopted a design-based research approach to develop the learning system and our authoring tools. So first of all, we consult language teachers, expert for a few times. So based on their opinion, we move to phase 2. We develop our system prototype. And then the next, we have the system put into implement in the real learning situation. We invite the kids for the pilot study to evaluate the system. And based on the result, based on the pilot study, we revise and modify the system again. So in total, we spend the cycle, we spent for 18 weeks for each circle and 4 cycles in total. Okay, so this is our final version of the learning system. It includes a robot, okay, and a tablet, and a set of toys. And you can see lots of sensors are embedded on the toys. So we have touch sensors, and we have a lot of NFC tags, and we also have a lot of barcodes, and we also provide the kids with the barcode scanner so that they can, interact with the the toys in multiple ways. And we embedded a Raspberry Pi, which is a microcomputer in here in the toy scale. Okay. Okay. So yeah, by doing so, we try to mimic a real scenario, like a shopping scenario for the kids to learn the vocabularies or the words that they're supposed to understand in a supermarket. Okay. And here's the so this is the structure of our authoring system. It includes 4 subsystems. Okay, let me just skip this one. And this is the interface of the script editor that we provided for language teachers. So you can see it's a graphical programming interface so that the teachers, they do not need to know a lot about how to program, right? They can simply specify the interactions. I want a robot to say this, after that, say that, right? Very easily by dragging and combining all this programming blocks together. And on the right hand, I mean, in this platform, the teachers, they can program the robot and the toy at the same time. So you see, 2 huge blocks here. So it's like when the toy send message go, and the robot will say something like this way. Okay. So this is our first version of our toy that we have designed. So it's really simple, right? We use a big cardboard box and put a picture of a bear with its mouth wide open. And inside of the box is a NFC reader. And we also designed a few, you see that, flashcards with the fruit patterns on it. So we create a story and we ask the kids, we tell the kids that the bear is hungry, so please feed the bear with apple. Okay, so the kids will bring the apple with NFC tag on the back to the mouse, and then the robot will say something. Wow, great job. Okay, like that. This is the first version. It's quite simple. And okay, this is our second version of the toy. Okay, we use a book. We create sort of a book, okay, kind of a pop-up book, to create like a shelves for the product items in the supermarket, right? And also we mark the price. Okay, next picture. You see that we mark the price on each of the products. And the same way, on the back of each flashcards, they are NFC tags. Okay, let me go to the next slide. Okay, here we go. Okay. So as you can see that the second version, okay, well, I forgot to say. So here we also create we also use a cardboard box to create a sort of a checking out machine, right? So the kids can bring the item cards in previous slide here, okay, and put it on top of here, and then the robot will pretend to be the to say, hey, it's $5, thank you, something like that, so that they can have conversation. The kids can learn the conversation easily. Okay. So you can see that actually the second version of our toys offer more realistic and enriched scenario compared to the first one. Okay, so this is the third version of our toy. So this time we use food models. So these are eggs and chocolate cookies, okay, and then milk or something. And you can see in the back are the fruit models. Okay. Okay. So in this version, it allows the children to engage more like physically, right? They can really use their hands to like grasping, picking up, or setting down items. And moreover, this version offers even more realistic and detailed scenario than the previous versions. Okay, like this. This is the third version. It's all the same that we embedded microcomputer inside of the toys, speakers, and NFC readers, and also the batteries. Okay. So this table, I mean, at the end, we kind of summarize the evolution of this the design of the toy, and we come up with some important principles. Okay. The first principle is that the design of IoT toys should be related to daily life experiences, right? So that young children learn what they learn. They not only learn, you know, piece of knowledge, but they can use what they have learned into their daily life practices. So makes the learning become more meaningful. And secondly, it's better to organize our learning materials around themes like shopping, food, or in the zoo, or in a farm. Okay. And third is it's better to use tangible objects rather than flashcards, because it allows children to do multiple manipulation. And fourth, using multiple types of sensors, because it allows children to interact with the toys with multiple sensory learning. Okay. Okay. So next, this one is the robot, the first version of our robot. Okay. So we use 3D printout. We made our own robot. Okay. It's very unstable. So let me just show you very quickly. Okay. So because okay, this is the version one, the first robot that we made by ourselves. We used 3D models to do it, and it's very unstable. So at the end, we kind of give up making the robot on our own. Instead, we just adopted the robot developed by a company in Taiwan, which is the KOPI robot here, version 2. And we also summarize some of the important principles in designing the robot. So first of all, I think it's very crucial for the robot to display facial expression on the face, especially while the robot is talking, because it's like human beings, right? Learning a language is not just about the language, but it also requires a lot of social cues from a person, from the speaker's face. So it's very important for the robot not just to, you know, blink the eyes, but, you know, to show face. It's very important. And also, it's very important for the robot not also to display the mouse movement. So you can compare in version 1 and version 2, they are a little bit different. Version 1, the robot doesn't come with the mouse, right? So it can only blink the eyes, but it's not very clear to the children whether it is the robots talking or some other devices talking. So it's very important also in language learning we also learn how to pronounce the words from observing the movement of mouth shape, right? Also, the third principle is that the robot must have hands. So if you compare version 1 and version 2, you'll see version 2 has the robot come with 2 hands. So in my experience, whenever I brought the robots to the elementary school or in kindergarten, all the kids there are crazy about the robot. They wanted to hold his hand. So the hands, they want to touch the robot, but not only with his face, but they want to shake hand with the robot. So hands are very important to like have physical interaction with the kids. And also because we use the robot for language learning. So, you know, when we express our thoughts, we oftentimes make a lot of gesture, like small and big, right? And tall and right, something like that. So with hands, robot can make more gestures and can help the children understand what the robot's talking about more effectively. Correct. So last of all, this is the modification of our authoring system. Okay, and I'll skip this part. Okay, so finally, okay, we conduct an empirical study using the learning system we have developed. But however, during the beginning of the research, we encounter another significant issue, which is that the children don't always follow, the script that the script interaction that you have wrote or you have designed. So my experience is that I invited children to the experiment site, and the little boy was too excited that he just jumped around for an hour. He barely had interaction with the robot. Even when he had interaction with the robot, he was like kiss the robot, holding the robot, right, and dancing and then jumping. He didn't really listen to what the robot was talking about, or he didn't really pay attention, too much attention to the interaction with the robot. So this made me realize that a learning system or learning material is not enough. We also need a learning support. I need to create some supportive mechanism to facilitate the interaction between the children and the robot. So this is why we conducted the third research. So we initiate the third research where we design a game script that involves the robot and children to playing the role of police officer together, so that the children and the robot has to they have to work together to solve a problem. They have to catch the thief who stole something from the supermarket. Okay. And okay, so from this study, we identify 5 key issues. Okay. First one is that I come to see that since the robot speaks English, in Taiwan we speak Chinese, Mandarin. Okay, so we noticed that sometimes the children couldn't understand what the robot is saying, right? So he has difficulties in understand the task instruction. And second, sometimes the children are being distracted. Just, they did not pay attention to what the robot was saying. They just, play the toys by their own, or they were just doing something else, by themselves, not even pay attention to the robot. And third, sometimes the children would, the nonstop scanning the barcodes or the QR codes rapidly. Okay. And the robot will be, it's out of the robot's response capacity. So the interaction would interrupt. And fourth, from time to time, the children would leave the spot. Sometimes they run off because they hear some of the sound outside or hear their classmates are talking. So they would just, run away from their seats and stop the learning task. And fifth, some of the children, they will stop, they are unwilling to continue the learning task if they try to answer the questions, but they fail. Many times they would just, giving up. Okay, these are the 5 main learning problems that we identified in this study. So to address this issue, we also propose several learning support, and yeah, in the right column. For example, we did the robot use gestures to facilitate its communication, like pointing, using the robot's hand to pointing, look at that, look at this way. Okay, so that you can catch the children's attention and help the children to understand. Now the robot want him to look at the tablet or to look at the toy. Okay. And also if a children leave the seats for a minute, which means that the robot stopped receiving any signals or receiving any messages from the toy, more than a minute, the robot would call out to the child, hey, are you there? Hey, Tiffany, are you still there? Coming back, I'm still waiting for you, okay? So, and also we provide scaffold for the children to help them to solve their problem. Like if they fail 5 times continually, the robot will, provide them hints. Okay, think about this. Maybe you can look that way. And I mean, by doing this, providing scaffolding to the children, like most of the children, they can solve the problem at the end, and that they would not giving up the learning task easily. Okay. So this is a little bit complex though. Okay. This is, we conduct an experiment, one group with learning support and the other without learning support, right? And then the pretest are the same, the pretest score are the same, and the post-test score shows that the group that was learning support, of course, they outperformed the group without learning support. And also we find that the learning support that we created or we designed can help to reduce the numbers of learning difficulties that during children learning with the robot, especially the learning mechanism, the learning support mechanism that we created, we designed, is more capable of reducing the non-cognitive learning obstacles. Okay, and here's are the pictures that we conducted our studies in the elementary school. So we have a lot of robots. Okay, so every time when we do the empirical study, we have to carry out a lot of robots to the experiment site. Okay, now I would like to share with you this video. I'm not sure if I can. Can we share with you? So, just give me a hold on a few moments. Okay. Can you see my screen now? Okay, let me share. I need to share another screen. This one. Okay. Please let me know if the sound coming up. Is there sound?
There is no sound, Miss Chen.
Oh, no sound.
Yeah.
Try it again. How can I excuse me, does anyone knows how to share the sound? Same time.
Maybe you can take the box in the bottom when you share the screen. There is a tick box in the bottom, and then you can share with audio in that
share with
box.
audio. Okay, let me do it again.
Okay.
Oh, I see it. Thank you.
Okay, you're welcome.
Okay, here we go. Is that sound?
Yeah, we can hear the sound.
Okay, maybe I'll stop the video. I'm here. Okay. Well, what I like the video the best is that you see the children, I mean, actually using the robot can encourage the children to to uh, to produce their language output. That they are more willing to speak the vocabulary they just heard from the robot. So I think that's one thing that I really like about the video. Okay, okay, let me go back to my slide. Well, okay, this is pretty much of my talk. So I will end my talk here. So any questions or comments or feedbacks?
Okay, thank you, Miss Jen. It's a great presentation. So in the background, some of my colleagues texting me that, oh my God, it's so cool. The robots are so cool. Okay, there are several questions in the chat room. So it's a message from Kristansil Huda. He said, undisputedly, Taiwan is very advanced in technology. Every citizen there is engaged in it for all aspects of life. So fantastic. And that is from Mrs. Nuris Ilah Rahayuning. It's really cool stuff, Miss. Pardon, but allow me to ask, is your robot support learning method to interact with children, to learn child with abstract object, maybe to assist them to learn about abstract objects? That's a question from Miss Nuris Kila. Oh, there are so many questions for you.
It's really interesting topic.
I'm sorry, your voice is muted. Okay. Is there any problem, Miss Jack?
Oh, thank you very much. I'm able to speak again. Thank you.
It's
Thank
okay.
you so much. Okay, sorry. I don't know what happened because after I shared the videos, then I was muted again. Okay, let me
Okay.
well, there are so many questions. I don't know which one. Okay. Maybe I look at the first one. I see which one's the
It's from Rizky Rahayuning.
um what is the difference? Oh no. Um
It's Can the robot help
Taiwan is a
to
very
help children to learn about abstract concept, maybe?
Oh, okay. Oh, it's really cool stuff. So robot support learning methods interact with children to learn child with abstract objects. Abstract objects. All right. Yeah, we use robot to learn. I mean, the study that I shared were the research that I have conducted in the past. But currently, because I'm working in the Department of Early Childhood Education, so I'm also create picture books for the robot to read, which is abstract concept, right? For the robot, we read stories, storybook, picture books to the children to help them to learn social emotional learning. For example, they will learn like how to be aware of their own emotion and to be aware of others' emotion and how to explain or how to reason why that person will react that way. Okay, so yes, we did. We also now we also conduct some of the research helping young children to using robot to learn abstract the objects. But yeah, I think it needs a lot of domain knowledge. Like, for example, if you're using robot to learn emotion, social emotional learning, then in your team, you need to recruit expert working in social emotional learning area so that the expert can provide you more like structural ways to design your learning or lesson plan. Yeah, that would be more effective. And okay. Thank you for this one. Taiwan is very advanced in technology. Every citizen is engaged. Wow. Thank you for the comments. I would like to welcome you to Taiwan. All of you, I can share with
Oh, I
you
would
my
like to go
lab.
there.
I can like tour you around in Taichung City. Okay. So also, let me read this one. What kind of technological innovation need to be implemented by teachers in this case? Oh, in this case, actually, teachers doesn't need to. I mean, but let me say it this way because this is uh, actually we are continue to improve our system. Like after the the study that I just presented, I continue to improve it. So now currently the teachers doesn't need to install any system, like doesn't need to install any technical platform. They just they just added the script using Excel sheet. So they just, yeah, Excel sheet. They just specify, okay, in the first timeline, the robot would say something, and then with what kind of facial expression, because we have all the animations for the robot's expression ready. So they don't have to make their own like facial expression. They just name it. I want, video number one as the robot's facial expression or happy smile or talking. Okay. So they know this is also what I try to improve, because many of even though we have done develop such a system, but still a lot of language teacher will they suffer. They say, oh, it's still too difficult for us to drag and to draw all this to edit the script by ourselves. So I managed to use a Excel sheet for the teachers to edit the script, and they like most of them can create a learning task or a learning lesson plan within just one day very quickly. Okay. Maybe I hope that I may have chance again to share with you. Okay, this may be very effective. And also, what do you think technology can be effectively used in education without being misused or even making students less effective? What are the ways to address this issue? Whoa, that's a very important issue. This is I often encounter because in I was conducting research, empirical research in kindergarten, and I can see actually if because a good design of technology is very important. If the poor design, children may get distracted very easily, or the children may use it in a not the right way. For example, whenever I brought the robot to the kindergarten, and the little kids, they just use patiently very quickly. If my robot doesn't respond immediately, they were like, I don't want to learn with the robot. Teacher, I want to play games. They just, they don't want to continue the learning task. They will just, right away, they want to play with the apps, those games like embedded in the robot. Yeah, so I think this is a very good question, but I haven't figured out how can I solve this difficult problems, but maybe you can do the research, okay, and let me know your result, okay. Okay, and the next one, to what extent does the development of robot media help teachers in the learning process development? Help teacher, in my experience, because most of my students, they are pre-service teachers, and a lot of students, they come to me. I mean, at the beginning of the class, they will come to me, teacher, the reason that I enrolled in this program is because I don't like computer, and now you're asking me, to do the project with the robot. So they complain to me a lot about this, but since ever since that I provide them with the Excel sheet, and they figure out, oh, actually this is very easy, right? To create a script, just, typing in the Excel sheet, and everything will come out automatically. And especially starting from next year, we have generative AI, right? So it makes everything, even creating a picture books, even more easily. So I think it really helped my students develop their technology literacy. But of course, I think at first for them, it is very challenging. But, with the advance of technology, I think most of the teachers, they are more willing or open-minded to accept the challenge. But also they at the same time, if you guide them well, they can I mean, it really can help them to develop their capacity of being a teacher, that they can make digital learning materials. It really helps them to build their teachers' professional development. Okay. I don't know if I answer your question or not, but that's all the questions there. Good question. Yeah.
Maybe 3 more questions, Miss Chen, because at 9 we will move to the next speaker.
Okay.
Maybe, okay.
Okay, maybe look at this. How long has the robot been developed, and what is the challenge of the development? Okay, how long? How long? It's really long. I think it's more than 10 years. Well, when I start working on this project, it's over 10 years. So what are the challenges? There are too many challenges. I cannot detail them one by one now. But I think with the help of generative AI, it's all become a lot of easier nowadays. So I really hope that one day I will have chance to share with you. Okay, maybe next year I will start working using my robot code, work with AI, so I can give you the answer. Okay. Okay, the second question. Okay, these robots are very interesting in supporting children learning. According to your experience, how the robot is best used classically, individual. Oh, this is also a very good question. The robot should be using individually or in a small group. Oh, my personal experience is small group. And the group number is supposed to be 2 or 3, not more than 3. Okay, because they will fight. Okay, oh, it's my turn, touching the robot. It's my turn answering the question. And then turn out nobody pay attention to the robot. They will just fight with each other all the time. Okay, so yeah, that's a very good question. And if the child interact with the robot individually, somehow they are not familiar to interact with a. They know that's a machine, right? So they kind of shy. I don't know why, but that's my personal experience. Whenever they interact with the child, with the robot alone, they tend to be more shy and then, low motivation. But two students, they would discuss with each other. Yeah, that would be better. Okay, the last question. How can we design a learning plan that incorporate robots and IoT toys, create contextual learning environment, which while facilitating the holistic development? Wow. This is also a big question. Yeah. I don't know. I don't know how to answer that question, but I can only provide a few principles that I just mentioned earlier to design a learning plan. I think there are certain guidelines you need to follow, especially from the language learning side. You have to choose the tools or the scenarios that are related to their everyday life experience, and you have to organize the learning materials in a thematic way so that they learn things, right? They just not get the piece of knowledge, but they use what they learn into their daily life practice. Okay, all these important principles that I mentioned earlier, but I think this is also a very good research topic, and I would encourage you to consider doing the research in this topic. Okay, so I think my
Okay.
time is up. Okay.
Yeah, thank you, Mission. I understand everyone is very enthusiastic with your presentation because wow, it's new thing for most of us.
Thank you, thank you.
Yeah, but unfortunately our time is up. So I would like to thank you so much for bringing so much insight today for everyone here. And thank you very much. So Miss Chen, I'm sorry we can move to the next participant.
Okay, thank
Oh,
you.
oh,
I wish
oh, there is
great
this message
success.
from the committee. May we ask your email for
Oh,
the for
sure.
the
I'll leave my
participant?
email in this chat box.
Okay.
Okay, okay, okay. Thank
Okay,
you
thank
so
you.
much for having me here.
Yes, thank you so much, Miss Chen. So I will return the session to Miss Mila.